All right. Well, I actually finished editing, uploaded this video about 2 days ago, and realized that the quality I was putting up on the video I'm working on, this is Brainstorm, wasn't up to my standard. I feel like whenever I upload a video, it should be helpful. It should be at least showing the demo of what I do in the project. So I decided to private it and delete the video and re-upload this one, basically re-record everything. As you can see here, I already finished the room. Brainstorm is part of the offensive pen testing learning path on TryHackMe, and I'm just going to show you this snippet from the old video I was doing. So there it is. So this is the actual video that I was upload. The reason why I privated, and this is me finishing the room and everything. You can see here it say Brainstorm on the top left. And the reason why I decided not to upload, because mid video I was recording this using OBS, and I have two VM running and also OBS running. And the resource on my computer is really lacking. So when I run two VM at the same time with OBS, it's basically take up all the resource. What happened is the video encoder that I have running, maybe it just the AMD graphics card I have, it just overloaded. And once it's overload, everything become to pretty much corrupt. It doesn't run normal. You can't the frame, it just it doesn't show the way it should be showing, so it just stuck one frame at a time every 5 minutes. So I decided to private this video and upload a new one. You can see here I'm already started my nmap scan with Brainstorm. I'm also just gonna have to full screen this actually. 1 second. All right, so as you can see here, I'm not gonna show you any answer, not at least not the flags, but we'll look into the port that we see here. There are 3 ports, so let me switch back to the VMware. There it is. It should say port 21, port 9999, and there's another port that should be opening. It's almost finished scanning, so let's give it a minute. All right, while it's finishing up scanning, I'm just gonna explain what's going on with this room. This room is pretty much part of the Buffer Overflow section. We're not going to do much of enumeration on this room. We're going to go straight into the Buffer Overflow part. The only thing we want to note is there are 3 ports, and the next thing is we could launch FTP to look at this exe. So we could go to FTP and paste the IP of the target machine. We can name it as anonymous without password, and on this room, it's a little weird or a little baffling for the first time. If you type dir on this, it's basically going into extended passive mode, and what it does, it just takes so long to get a response back. Sometimes it doesn't give you a proper response. So what we want to do here is to type passive to turn the passive off, and then we could do dir again. See here, it's show in ASCII mode or something like that, but like it cannot open data connection. We could try it again, and there it is. We could see the directory chat server, so we could cd to that, and then we could dir again. As you can see here, there are 2 files we could download. So before we download the file from this FTP, we have to type binary. What it does is basically enable us to download the file in a like straightforward manner. Some reason, if you turn this off, it just like completely break off the download to like a certain percentage. It just stopped working. The binary allowed us to get it 100%, and if we try to get chat server like this, see here, it download the full file at 100%. It should be 4.3 megabyte, I think. And we could also download the ess fung.dll. Oh, not cd, what am I doing? Get ess fung.dll, and that's what we could get. That's all we could have in here. We could exit now. We could go back to our nmap. Again, there are only 3 ports that are open. Port 21 is the FTP we just log into, and port 3389 doesn't do anything. It's just like a basic Microsoft web server, I think. And port 9999 is the Buffer Overflow, or basically the program we try to get the Buffer Overflow exploit to work. So we could try NC for netcat, and we could paste the IP of the target machine, and we could type port 9999 And what it does is basically showing us this executable or binary, and it's basically a chat server that we could input our username and our message. And if we type a message, gonna say our username set this and whatever, hi or whatever. So this is what we want to exploit, and to do that, the only way to basically get our exploit to run is to test it. By doing so is we need to basically get a VM for Windows, and I see video of people using Immunity Debugger on Windows 7 or 10. You could use that too, but the thing with Windows 7 and 10 that it is so outdated that Microsoft stopped allowing us to download the ISO, but you can still get it from Internet Archive and whatnot. Or what I tried to create a Active Directory work home lab was with the Windows 10 server evaluation, something like that, or a Windows Enterprise, basically a Windows 10 Enterprise. It can work, but in my opinion, I prefer Windows 11 for one reason and one reason only, is to have terminal. You could get this on Microsoft Store on Windows 10 too. But the thing with terminal is it's allowed us to run both PowerShell and command prompt, and also Azure Cloud Shell. But we could type ls, which is, you know, a Linux command. The thing is, this is more modern, it's more updated, it's more clean. I prefer this more. And also you could get the Python 3 version. There's 1.2.7, which I'll explain a little bit later. Python 3.12, you could also download it from the Microsoft Store too. I prefer running Python 3.12 over the 2.7 because it's basically more up to date. But anyways, so how can we transfer all our file that we needed? I recommend storing it on a folder, and on this room, since we are running Immunity Debugger to debug the binary, is the Immunity Debugger. We're going to use Immunity Debugger to debug the binary to get the exploit to run. So you could basically Google Immunity Debugger and go to download latest Immunity Debugger here, and basically put your information, whatever you want. It is, you know, I'm not recommending anything. Just do whatever you feel like doing here and get the download. And one other thing you have to download is the Mona.py. So Mona.py is basically what we run on the Buffer Overflow prep room. It's created by Corland, and the simplest thing is, you know, just get this script Mona.py and store it in the same folder. I store mine on the download folder on Kali. So this is the two things we want to download. So Immunity Debugger and Mona.py. Launch another tab. Let me launch two more tabs here. Actually, one more. And then I'm gonna cd to home download. And I'm gonna ls here. You can see here there's chatserver.exe, essfunc.dll, and Immunity Debugger setup.exe, and Mona.py. And we could run a Python server with Python 3, basically TACM HTTP. TACM is for module, I think, and then http.server, and type whatever port you want to set to. And we could do a IPA to look at the IP. We can copy the Ethernet 0, which is the local IP we want to use, and basically copy it to our Windows VM. And if you launch it on the browser, as you can see here, we could download all the file like this from the server that we just simply launched from here. And you see here, if I try to download Mona.py, actually, if I try to download this, it's gonna try to block us and everything. So the way I set all of this up with the Windows 11 VM is to basically turn off all the Microsoft Defender. There should be a script on GitHub somewhere. You know, be careful on what you install. I basically loop the IP using this network command here. It should be in advanced network, I think, and then Ethernet 0. You could edit this, and basically on property, it doesn't really matter. This is all local IP. So I would use this to set the default gateway to my local IP and whatnot, and basically get it to run without connecting to the internet. So obviously we don't want to connect to internet on our Windows VM here, since everything is turned off too. But we are in VM, so the likelihood of VM escape is pretty low, very low. So low chance of like any vulnerability. As far as I know, you know, we could download the thing we needed, and with Immunity Debugger, when we install it, it's basically allowed us to also install Python 2.7, and what it does is basically you could run Python server and stuff from here too if you need. That's it for the VM setup. It should be pretty basic if you've done this before. Straightforward. It take a while though. For me, it took me a couple hours to just figure all this out, but you know, I done with other thing with the Active Directory, which takes much longer, to be honest, to join everything up into a server. But this is fine. So this is all we need, Immunity Debugger. So the thing is, I'm going to use Mona the same way that Buffer Overflow Prep Room did. And you could store Mona in basically C program file x86 and Immunity Inc. and Immunity Debugger. And you could place the Mona.py in py commands. This is where I store the Mona. Let me launch it like this. You see here, Mona.py should be in here. So once we have that, we could basically run Mona and basically set a working folder and whatnot. So the next step here, before we do anything, we can set up a working folder by using this command. So everything you follow should be straight from the Buffer Overflow Prep Room that I did a couple weeks ago. So this is the command we're going to use: !Mona configs pack set working folder at cmona and a %p, which is like set a file based on the name of the binary we're gonna try to debug. So this is where it's gonna set at. And if you could open this on Window Explorer or exploit.exe, you can see Mona file here. You can see chat server, which is I haven't launched the binary yet, but we'll do it a little bit later. So basically right now actually. So want to open up the chat server. I basically store everything in a folder on desktop the same way. I mean, you can store it anywhere basically, but I prefer desktop because it's easier to reach. So this is the chat server that we download from the FTP and the ESS-fung.dll. We can open that on Immunity Debugger, and we could full screen this, maximize it. We could clear up the workspace, make sure it's, you know, have a little bit of space, whatnot, easier to look at. And what I recommend with Immunity Debugger, the first time you ever launch it, you could change the font size, make it a little bit bigger. I already done it. So you could go to option, appearance, and font. You can click 2-tap and then go back to font, and you could click on change, and that's how you're gonna change the font size to the size you would like to look at, for those who have problem looking at small text basically. All right, so we have this kind of running. We could press the red button play, or red play button, to get it to run like this. So what this binary do is just waiting for a connection, the same way we did the netcat on here. So you can see here, it's just like welcome to Brainstorm chat, same like this. This is the other end of the binary. It's basically waiting for the connection. So if I do nc, what's the IP of this? I think it should be the local IP. I think it's like 242.130. So it should be this. If I do this 999, connect. Let me try looking the IP configs. Yeah, it should be the right IP. It doesn't connect though. Let's see. Let's try running it without the Immunity Debugger. We could close that for now and launch the chat server, and then we could try netcat again. Yeah, so this is fine. So this is basically the same binary that we got, and port 999 is the Abyss port from the nmap. So this is how the program is running. You could also check it by running the netstat. Let's see, netstat pack ANO. So without the binary, we don't see port 999 on here. It's just completely blank. And when I run the binary, let me change the CMD on this and CD to desktop and chat server. Brainstorm, actually, that's the folder. And then I could launch chat server like that. And if I do this netstat ANO again to look at the opening port, whatever listening and whatnot, you can see port 999 should be here. So it's basically listen to any address coming in at 00. So like it's open to any address. So basically that's the basic binary that we're looking at. So we could restart the Immunity Debugger again. We already set the working folder. Now we're gonna switch back to our Kali machine, and this is the fuzzer that I'm working on. So we compare the two fuzzer. Actually, I'm just gonna open up a GitHub by Tiberius. So everything we use on here is basically from Tiberius GitHub write-up. This is not the actual write-up for the room. It's just a basic like script for pretty much any Buffer Overflow related task, and this is the same script came from Buffer Overflow prep room that created by himself, Tiberius. You should know who he is. He is a pretty well-known content creator for cybersecurity or like hacker and malware reverse engineer and whatnot. So this is the same script that we're using with. I'm just gonna change it slightly, basically implement a new kind of couple new line into this with the help of ChatGPT, of course. But the switch up on this is to change the connection. So this part is I changed it to as connect IP port. For some reason, when I run the fuzzer.py on with the original code, it's just not letting me connecting. So if there should be a fuzzer.py here. So if I add Python 3 fuzzer.py, it does this. So it is the same IP, but it couldn't connect to the IP for some weird reason. So this is the same IP that we look in. This is this IP here. Again, this is the IP that we're looking at. You can see here 192.168.242.130. So this is the IP, but it just doesn't connect. So I modified a little bit to make it to work. So this is to grab the banner to get the connection, and we could send the username since the binary asks us for the username, and it's gonna print how many bytes it passed. It's basically scan 100 bytes at a time. This is what we look at. So that's the buffer and how many bytes it sends, and basically give us an exception. If it could not connect, it would say cannot connect to the IP and port. And another exception is like an error occur. That's basically it. It's pretty simple. It took me a while to like figure this out, but I'm pretty novice in terms of like writing Python script in general. So if you're more proficient in writing Python script, I'm sure it's gonna be much more efficient than I did. So let's move on. So we could try to fuzz the binary with the modded fuzzer.py here. So I could cancel this connection. Okay, make sure it's clear out. CLS on this side, CLS2, clear this out, minimize this, restart it again and make sure everything is completely fresh. So everything, if it crashed, you could restart using the two black backward button here, and then we could run it to get the binary to launch, XEX to launch, executable. So first thing first, I can name this, Alt Shift S to name it. I would say fuzzer, name the tab here. We could name this as Metasploit. We could name this as basic netcat. So netcat, you could name this as exploit. All right, so that's all we need for now, and we have everything done. So I'm close some of these tabs out, clear out our space. That's it. So we could try fuzzing the binary or the application by typing Python 3 modded fuzzer.py. This is the script that I modify. It's basically going at 100 byte in a time, and when it crashes, it's basically going to stop at whatever bytes it is. So it's going 100 bytes in a time. It should stop in 2100, my experience. Yep, so it stopped here. So that's it. Let's say timeout. That is good. So far, we know that the binary crashed at 2100. We can switch back to the window VM. You can see here the EBP, the EIP is at 41. It say 41, 41, 41. So everything say 41, 41, 41. What it means is just basically an AAA. So that's how it crashed. So it say AAA everywhere basically. That means that we can control the binary basically with the fuzzer. So we could restart this, launch it again. So following the step from Buffer Overflow prep, we can say that we could run the Metasploit framework, this framework here. Let me look this line up. So yeah, that's it. Pattern, not offset actually. I think it pattern create. So we could use this Metasploit frameworks. It's in user share Metasploit hack framework in tool exploit pattern create.rb to basically create a basic pattern for the binary that we could put in our exploit payload. And the payload, this is a little bit spoiler here, but let me copy and paste the fresh payload first before I do anything. Hold on. All right, so this is the fresh exploit.py. So we could copy and paste the result of the create pattern.rb, the Metasploit framework, into the payload, and we could change the IP to the to this IP. This is the window machine VM IP for now. This is the local one for now. That's all we need for now. You save it, go to the exploit tab. Since the binary is already running, I think. Yeah, it is running. Let me double check again. It's running. Okay, we could run the exploit.py. It's basically send buffer, and it captured this, so that is good. The next step on here is to find the offset. So basically we use this command for Mona on the bottom left, or at the bottom of the program. We can copy and paste this, or just basically write it. Basically say exclamation point Mona find MSP at distance 2500. The reason why we generate 2500 bytes on here, I forgot to explain this. So we did fuzzing and it stopped at 2100 bytes. We need to add 400 bytes more into the pattern to basically get over the buffer basically. So we generated 2500, and basically we try to find the 2500 on Mona here, basically looking for the offset of the program. It's basically it's say here too, so examining, it should be examining register this part. Let's say EIP contain normal pattern and the register address, and let's say offset is 2012. So to verify that we on the correct offset, we could try using this command pattern. So the same similar command, just change the address. Actually, let me look at the address. Same 31 70 43 30 31 70 43 30. So it is the same. Okay, that's good. So it is pretty much on the same file, the same directory. It's in a, but the file say pattern offset to find the offset, and the length of the bytes, basically like the payload that we just sent to 2500 is the length, and the queue, I think it's just the register address. Not completely sure. Actually, let me, I do help. And I can check. Okay, so query is what we want to look at, but it's basically say the address of it. So this is the same address, 31 70 43 30, same address as this, and what we get for the offset is, to verify it, it is 2012, which is great. So that's what we'll look for. With that, we could go back to the Python exploit, the exploit.py. You type 2012 for the offset, and we could save, actually we could save that for now. So that's the first step, to find the offset. The next step is to generate a basic 00 byte array on here. This basically combine two steps at the same time. So if you're on Buffer Overflow, there should be a looking for the return BBB. I'm gonna do it the same at the same time as this one. So I'm just gonna generate this first. So what it does is to generate a basic byte array for 00 to x00. That's completely default. We can go back to the CPU thing app here, and we could restart the binary and run it again. With that, on our exploit, I'm just gonna add BBB for the return address, and I'm just gonna use this Python script from the same step as Buffer Overflow prep. This script is basically going to generate a you can see here it's Mona byte array tag B00. That's what we used earlier on here on the Immunity Debugger, and this Python script here from future import print function, and it is a for loop, I think. It just basically print this out. So what I'm gonna do is to do a python 3 bytearray.py. This is what it does. So if I sublime bytearray.py here, but this is the same command, the same script from Tiberius. I think it's just like a slightly modified one. It's the same. This is, I copied this straight from the Buffer Overflow prep, but what it does is just basically print this. It is pretty much the same as the x00 we just generated. So if one trick I like to do this is when I compare thing on from this window VM to the Kali machine, is to run a Python script, Python server That's why I prefer running Python 3. So if I do Python, let me cd to Mona first. Actually, cd to Mona, it's stored in C, so I don't need to type C colon or anything. Just go to Mona and then it does it by itself when you press tab, so that's good. And we could run a Python server to compare. For now, HTTP server port 80, it's running on this port, and quickly go to that on my browser. You can look at the byte array.txt, and if I'm comparing this to what I just generated with the with this script, it's basically the same thing. You could look at the N here and this, it's basically the same thing. So the reason why we want to generate this is to basically test this payload to the payload we just generated on the byte array x00. So we could copy this result from the byte array, copy it and paste it on our payload section. We need to put a parenthesis on both ends of the line, so that's all we need to do, and we could save it. So remember that prefix and padding is still blank, or postfix is blank still. Don't need to change anything, just change my username to my username basically. Now since we are already generate this, so again we generated with the byte 0 the x00 this. So we basically want to test this with the thing we just generated. So with this, the payload we just generated, it is pretty much the same thing, to be honest. No different. It's the same line and everything. So don't get confused. We just test this out and see if it match. And if it match, it mean that we can go ahead and exploit further. That's basically what it means. So go back to CPU tab here. Make sure it run. Save my exploit. So this is all we need. We have the return section at BBB, the offset at 2012. We just found the offset, and the payload we just copy and paste the result of the byte array.py. Now we could run the Python exploit again, send the buffer, and you can see here the EIP, it changed to 424242. What it mean, it basically when we type the return address to BBB, which is translated to 424242. So we basically have the control of the EIP on this. That's the simplest explanation. With that, since we just send a new payload, we could compare the payload with the default payload. Now all I need to do is to copy this line here to compare the Badchar or bad character, or the same way we look at the payload. So all we need to do here is to write down the ESP with this command here. It is exclamation point Mona compare tag F and the path of the byte array.bin. So it is in Mona chat server byte array.bin, and then tag A for the address. We could type the address with 00A3EEAC. So what we want to look at is to see whether or not the address is unmodified. And if it is unmodified, it's mean that we have control of this, and we could type the right bad character to avoid the bad character and basically capture the buffer overflow to get the exploit to work. With this binary, the rule maker kept it simple. It should be more than this step. It should be more than one step. But the thing is, with this binary, a little bit of spoiler here, or we're gonna see it soon. Basically, the room creator kept it very simple. That they basically kept everything pretty default in terms of the bad character. So this is the only step we need to do. And if you press enter to compare the payload to the byte array that we just generated, it is pretty much the same. So it's unmodified. So it's the exploit basically successfully running. So we could use this as our exploit. So we could remember the address here, so 00A3EEAC. Since it's say modified, we don't need to do anything else. That's good enough. So with that, we could copy the address. Actually, let me copy this other line. So with the result, which is fine, we could copy and paste this line from the buffer overflow prep steps to find the jump point of this. So what is the Badchar, the bad character on this machine, on this binary? It's basically x00. Again, it's pretty much default. So the creator want to keep this simple. So x00 is what we want to type in to our search to find the jump point. So when we press enter, it basically show us the jump point of this. So this is the jump point for the ESP at the ESS func DLL, and we could type this in backwards. So we can start with DF 145062. So that should be our return address. So we could type xdf. So make sure you start everything with x. So backslash x df backslash 14 backslash 50 and backslash 62. Now we could add the padding for this. It's basically a no-op padding. The same step from Buffer Overflow prep. Again, this is just me learning how to use the Buffer Overflow exploit. So everything has been followed from the Buffer Overflow prep room, and we could time the no-op by 16. Next step, we could generate the NSF Venom to get the remote code execution. We could type NSF Venom, and a little bit spoiler here, but we could do this first. Where did I type my IP? I could close this. This is fine. IP tag A, and I could copy the local IP for now. So what we use for our remote code execution to generate a payload is to type NSF Venom tag P for the payload. For Windows shell reverse TCP, this is the unstaged payload. For L host, which is the local host we want to use for now, is the test between this two computer or this two VM. I'm using this IP for now with the Ethernet 0. So it is 192.168.242.128, and then for L port, the local port, we want to listen with our netcat. We could use port 4444, and then exit function. This is follow from the Buffer Overflow prep, so kept that default, and tag B for the Badchar. I think since it is the Brainstorm room creator kept it simple, we're gonna use this as the Badchar x00. That's our Badchar, and then tag F for file. I think it's compile it in C or C file basically. So once we press enter, it's basically gonna generate a payload for us to copy. So we could copy this payload, paste it on the payload section in the parenthesis on both ends, save it, and then now we could go back to our terminal, launch a vertical screen, a vertical tab on this, and run netcat pack lvnp port 4444, and then close, go out to our window VM, exit on everything. So we find everything we need to find. So exit on all of this. I like to maximize this so it's cleaner. And since I'm on the terminal here on this, if ls, you could see, oh, not ls, CMD doesn't recognize ls actually. That's funny. So you can see chatserver.exe. We have to launch chatserver.exe outside Immunity Debugger. So I recommend using the terminal to do it. To be honest, it's much easier to close it and restart everything. So have this running the same way that the netcat was from earlier, from this, same way as this. Now we could run our exploit, and we get the Buffer Overflow to run locally though. So if I type who am I, so this is the desktop and IP configs. You can see the IP here, 192.168.242.130. That's the local IP for this, basically this. So that is that for now. Could cancel that. If I type IP configs on here, that's the same IP on here. So that's all we need. We basically got everything to run. So close out this, run our netcat again, go to our exploit, not yet, go to our Metasploit tab here, generate this. So all I need with this is to generate my ton0 IP. So if I type ton0 on here, IP tag A. So this is my ton0 IP, which is 10.13.47.211. This is the TryHackMe VPN IP. Oh dang. Okay. Go back again. Copied the wrong thing. It's okay. So we type lhost on this equal to 10.13.47.211. That is our ton0 VPN IP that connected to TryHackMe. We could generate that, copy the result, replace it with the old payload that we connect to the local machine, to the local VM, and then change the IP of this exploit here, the IP section, change it to the room IP. So if I switch to this tab, almost an hour anyways. So I copy the IP of this back here. We could paste the IP of the room, save it back to our exploit tab. We already run the netcat. Now we run the exploit again. So this is all we need to configure. So the offset 2012, again the return address df 145062, we already found that. The padding, we just add the no-op times 16. Payload is what we generate with the NSF Venom. So that's all we need to configure. Go back to our exploit tab and run the exploit. That's it. We should get the connection. If I type who am I, NT authority, so they kept it simple, so we don't need to privilege escalate or anything. So if I type ipconfigs, this is the same address as the TryHackMe room. That's all we need. So there's only one flags here. So we can cd to user for now, and then type dir. You see Drake. So Drake is the user in this machine. There's no administrator folder or user. So we can cd to Drake, desktop. Should do this in one line, but I make it long. Anyway, cd to desktop, actually no S. And there again, and we can see here root.txt. It is stored in 08 2919, so there's no way I could go back in time like this. So this is the root.txt. You should be all set. I'm not gonna print the root flag, obviously. Now, actually, it's a really good, rewardful room or experience. I'm still figuring out Gatekeeper, which is the next room I'm working on. But anyways, this is all we need to do. Date, which is today's date. There's a 10/03/2024. That is the room.txt. I already completed this room, obviously, and obviously the recording was broken, but got it done under an hour. That's good, which is honestly the first time it took me almost a week to look around to manage to like configure all the Python script. But anyways, that's it for this video. Not gonna print a flag, sorry. You have to go through it on your own. I recommend doing so. But anyways, hope this helped. Hope you have a wonderful day. Take care.